Welcome to the Tech Life Well podcast. We're delighted to have you with us.
Where we make technology simple, thoughtful, and useful. For more insights and episodes, visit techlifewell.com.
I'm Ariel Wells. In this Tech Life Well podcast episode, we explore the challenge of measuring AI intelligence beyond simple accuracy. It is easy to get caught up in the hype of a single score or leaderboard ranking, but the reality of innovation demands a much more nuanced approach. As we move from chatbots to autonomous agents, we have to look beyond who answers the most questions right and start measuring reliability, reasoning, and safety. We're shifting from a culture of leaderboards to a culture of scorecards, and understanding this shift is essential for anyone trying to navigate the future of technology.
So I feel like we have to start with the elephant in the room, or I guess the elephant in my social media feed. Every single week, it feels like there's a new king of the hill.
Oh yeah, every day.
You open up X or LinkedIn, and the headlines are just screaming at you. You know, this new model crushed the bar exam, or Model X is now smarter than a PhD student.
It's relentless, isn't it? And honestly, it's exhausting, even for those of us who track this stuff for a living.
It is. And it creates this obsession with what I've been calling AI IQ.
Right.
We want a single number.
Right.
We want something that just tells us who's winning.
No.
Like a batting average in baseball, or, I don't know, a horsepower rating for a car.
We want it to be simple.
Exactly. Okay, Model A is a 95, Model B is an 88, so Model A is better. Case closed.
Well, that's just human nature, right? We crave simplicity. We love a leaderboard because it saves us from having to, think too hard about the details. But I think our mission today is to really explore why that mindset is actually becoming, kind of dangerous.
Okay.
We're looking at a stack of research here, including some really fascinating work on agentic AI that suggests the industry is pivoting hard.
Pivoting away from the high score.
Pivoting away from the single score.
Yeah.
The sources are pretty clear on this. Smart isn't just about passing a multiple choice test anymore. The industry is realizing that if we want to integrate these tools into, actual businesses or our lives, we need a scorecard approach. We need to measure adaptability, reasoning, and safety as separate things.
Scorecard versus leaderboard.
Yeah.
I like that. But before we get into the scorecard idea, I want to dig a little deeper into why the old way is actually broken.
Okay.
Because, playing devil's advocate here, if a model gets 100% on a test, isn't that just objectively good?
Yeah.
Why are people calling these leaderboards misleading?
It all comes down to what you're actually testing. Think about it like this. Most of these benchmarks measure accuracy on a static data set.
Okay.
So imagine you've got a student in a history class, and they manage to get a copy of the final exam from last year. They memorize every single question and answer.
They're not learning history, they're just memorizing the string of letters. A, C, D, B, A.
Exactly. They don't know why the Battle of Hastings happened. They just know the answer to question 4 is 1066.
Right.
If you give them that exact same test, they get 100%. They look like a genius. They're king of the hill.
But if you change the wording of a question just a little bit or ask them to apply that knowledge to something new,
they crumble. They have zero understanding, only recall. And that's where the stakes get higher, because the sources talk about the rise of agentic AI.
Right, agentic from agency. These aren't just chatbots anymore.
Correct. We're moving past the era of write me a haiku about a dishwasher.
Right.
We're entering the era of plan my entire travel itinerary, book a flights, and sync it with my calendar. These systems are designed to use tools and take action.
And that completely changes the risk profile. If a chatbot writes a bad haiku, who cares? I roll my eyes.
Exactly. But if an agentic AI is trying to optimize your schedule and it decides, the most efficient thing to do is just delete your database or cancel a non-refundable flight because it misunderstood a prompt.
That's a catastrophe.
It's a disaster. So accuracy is not nearly enough when the cost of being wrong goes through the roof.
It reminds me of hiring someone. I don't just want the person who got straight A's. I need someone who's not going to burn the office down when they get stressed out.
That is the perfect analogy, and that's why this AI IQ thing is trending so heavily in the enterprise world. Companies are realizing a high score on a test doesn't mean an employee is reliable.
So let's talk about the solution then, the scorecard. If we're throwing out the single number, are we trying to replace it with another, maybe more complex number? Like this AI has an IQ of 150. Is IQ even the right word?
Well, the sources actually warn against using a single number like IQ at all. It's just too reductive.
Too simple.
Yeah. Serious stakeholders, we're talking governments, banks, healthcare, They're demanding a profile. They want that scorecard.
Because a single number hides all the messiness.
It hides the trade-offs, and
Yeah.
there are always trade-offs. So imagine you have an AI model that's an absolute coding genius, scores off the charts on logic, but it has zero safety filters.
So it's brilliant, but dangerous.
Totally. It will happily explain how to build a cyber weapon if you ask it nicely. Now, if you average its genius coding score with its zero safety score, you might just get a medium overall score.
And medium tells me absolutely nothing about the massive risk I'm taking.
Exactly. It's like averaging my ability to cook lasagna with my ability to land a 747. One is pretty good, the other is non-existent. The average doesn't help you decide if you should let me fly the plane.
I am definitely not getting on that plane. Okay, so let's look at this blueprint for the scorecard. What's on the list? What should we be measuring?
The first one is reasoning and generalization. This goes right back to our student analogy. Can the AI solve a problem it has never seen before?
The difference between memorizing and actually thinking.
That's it. That's the core of it.
Okay, that makes sense. But I assume it's more than just thinking.
Oh, yeah. The next one is reliability and calibration. And this one is fascinating. Calibration basically asks, does the AI know when it's wrong?
Oh, that's huge. That's probably my biggest annoyance with the current tech. It just confidently makes stuff up.
It hallucinates with 100% certainty, right? A human expert, if they're not sure, they'll say, look, I'm about 60% on this, let me double check.
And that builds trust.
Exactly. A well-calibrated AI will say, I don't know, or this is my best guess with the data I have.
I would respect an AI so much more if it just admitted it didn't know something. What about the ethical stuff?
That's where safety and responsibility comes in. Does it avoid toxic output? Does it refuse harmful requests? And right next to that is fairness. Does it work equally well for a user in Kenya as it does for one in Kansas?
Or is it just biased toward its training data?
Right. And then finally, there's transparency.
Explainability.
Pretty much. Can the AI tell you why it made a certain decision? Because if a bank uses AI to deny a loan, the computer said no is not going to hold up in court.
Right. You need to be able to audit the reasoning. This all sounds way more robust. But does this actually exist yet? Or is this just an academic wish list?
It's starting to, or not all the way there, but the sources point to a couple of major benchmarks that are trying to do this. The big one to know is HELM.
HELM. Like on a ship.
HELM. It stands for Holistic Evaluation of Language Models. And holistic is the key word. Instead of one rank, HELM measures multiple metrics across tons of scenarios.
So it's not a leaderboard, it's a dashboard.
That's a great way to put it. You can look at the HELM dashboard and see, oh, this model is super accurate, but it's really inefficient, so it's expensive to run.
Or it's great at reasoning, but scores low on toxicity.
Precisely. It forces the user to decide what actually matters for their specific use case.
Yep.
A creative agency might care more about, well, creativity and less about efficiency. A bank only cares about safety.
That feels infinitely more useful.
Yeah.
But let's circle back to that reasoning piece. How do you actually test for smarts without just testing memory? I mean, these models have read the whole internet.
That is the hardest challenge in evaluation right now. And that brings us to maybe the most interesting benchmark in the stack, ARC-AGI.
REC-AGI. What makes it so different?
It focuses on what psychologists call fluid intelligence versus crystallized intelligence.
Okay, Psych 101. Break that down for me.
So crystallized intelligence is your accumulated knowledge. Knowing Paris is the capital of France, that's crystallized.
Stuff you memorized.
Exactly. Fluid intelligence is your ability to solve a new problem you've never seen before, just using logic and pattern recognition.
Figuring things out on the fly. MacGyver style.
That's it. And RRC-AGI tests this with these little visual puzzles, grids with colored squares. The AI has never seen them before.
Oh, like those human IQ tests. We have to guess the next shape in a pattern.
Very similar. It'll show the AI a couple of examples of a rule, like blue squares turn red when they touch a wall, and then it gives it a totally new grid and says, okay, solve this.
So it can't cheat. It can't look up the answer because the answer literally doesn't exist anywhere.
Exactly. It has to learn the rule in the moment. And the sources mention there's an ARC-AGI 2 now, which is even harder, designed to be resistant to any shortcuts.
So it's trying to strip away everything it read on Wikipedia and just test the pure reasoning engine.
And here's the kicker. Right now, even the very best AIs really struggle with it.
So they're trivia champions, but they aren't quite detectives yet.
That's a perfect way to put it. Not yet.
I want to pivot a little. We keep talking about AI like it's a brain in a jar, chatbot. But the sources brought up something called MIQ Machine Intelligence Quotient. And it was about cars.
Yes, this is taking the scorecard concept into the physical world. MIQ isn't brand new, it actually popped up back in 2008 or so, but recently researchers applied it to autonomous vehicles.
Giving your car an IQ score. I can just hear it now. My car's a genius, yours is a dropout.
Hey, well, hopefully they're all honor students. But the framework is really interesting. They propose 3 dimensions: physical intelligence, cognitive intelligence, and functionality.
Okay, what's physical intelligence? Like how good the engine is?
It's more about reflexes and control. Can the car stay in the lane? Can it handle a turn smoothly? Can it navigate a snowstorm without sliding?
Got it. And cognitive.
That's the brain. Can it recognize that the object on the sidewalk is a child and not a fire hydrant? Can it predict that a cyclist is about to swerve?
And functionality is just, does it work?
Pretty much. Does it take the fastest route? Is the ride comfortable, or is it slamming on the brakes every 10 seconds?
It's fascinating to think about buying a car based on a profile like that. You know, I need a car with a safety IQ of 140 because I have kids, but I don't care about its navigation IQ because I just drive locally.
But here's the caveat, and this is important. This is highly domain specific. A car with a high driving IQ is smart at driving. If you ask it to diagnose a rare disease, its IQ is 0.
Right, it's not a general genius.
And that just illustrates why we can't have one universal AI score. A medical AI needs a totally different scorecard than a self-driving taxi.
Okay, so what does this all mean for the person listening right now? They're probably not building their own AI. Why does this shift from leaderboards to scorecards matter to them?
It matters because of one word: trust. If we're going to let these things into our healthcare, our finances, our roads, we need a reason to trust them.
And trust me, bro, from a tech CEO isn't cutting it anymore.
Not even close. This connects directly to governance and regulation. The sources mentioned the NIST AI risk management framework. It demands trustworthiness, and they define it: validity, reliability, safety, privacy.
And the EU AI Act, too. That's the big one everyone's watching.
Absolutely. The EU AI Act focuses on these high-risk systems. If you're deploying an AI for hiring or lending, you need to show your work. You need to prove it's robust.
So standardized scores mean we can finally do a proper audit.
Exactly. Regulators can actually do their job. They can say, you claim your system is safe, but it scored a 40 on the standard toxicity benchmark. Explain that.
It holds their feet to the fire. But isn't there a risk here? I remember in school when standardized tests became everything, teachers stopped teaching history and started teaching to the test.
You hit the nail on the head. That is the philosophical danger lurking here. It's a phenomenon called Goodhart's Law.
What's that?
Goodhart's Law basically says that when a measure becomes a target, it ceases to be a good measure.
So if we decide reasoning is measured by this one specific puzzle, developers will just train the AI to be really, really good at that one puzzle.
Precisely. They'll optimize only for the metrics on the scorecard and neglect everything else. Or worse, you get something called data contamination.
That sounds bad.
It is. It's when the answers to the test are accidentally included in the training data.
Oh, God.
Yeah. The AI isn't learning to reason. It has just memorized the test questions because it saw them online. It looks like a genius on the scorecard, but in the real world, it's useless.
So we're in an arms race.
We are. An arms race between the testers and the developers. We create a test, they learn how to game it, so we have to create a harder, fresher test. It's a constant cat and mouse game.
It sounds exhausting, but I guess it's necessary. We can't just stop testing.
We can't. Without benchmarks, we're just flying blind. We just have to remember that the score isn't the intelligence. It's only a proxy.
So to bring this all together, it feels like we're witnessing a maturity moment for AI. We're sort of growing up, moving from my AI is bigger than yours to here is my AI safety profile, here's its reasoning capability, and here are its known limitations.
That's the hope. It's a move toward transparency. A standardized scorecard gives us the vocabulary to talk about what these machines can actually do and maybe more importantly, what they should do.
It turns a magic trick into a tool. And tools can be measured.
Correct. And measurement is the first step toward real accountability.
This has been really cool. It completely changes how I'm going to look at those headlines from now on. I'm not looking for the winner anymore. I'm looking for the report card.
And that raises one final thought for everyone listening. If we do this, if we successfully create a perfect, standardized AI IQ test, Will it actually help us trust machines more? Or will it just teach machines exactly how to game our systems? Are we measuring their intelligence, or are we just training them to be really, really good test takers?
Thanks for listening. Follow Tech Life Well podcast channel for more helpful episodes.